In this video, I'm going to be showing you how to solve rational equations. And that just means that there's going to be a fraction in your equation, and you just need to be able to get rid of it. So we're going to go ahead and start with example 1. So here's our first example. You have two fractions that are equal to each other, and this method is only going to be able to be used if you have one fraction equal to another fraction. Okay. Before you even start working this out, though, you might want to take note. If you look at the bottom of each fraction, x minus 5 is on the bottom of this one, x minus 2 is on the bottom of this one, that should go ahead and let you know that x is not allowed to equal 5 or positive 2. Alright, so now we're going to go ahead and get started with this problem. What you're going to want to do is you're going to want to cross multiply the top of the first fraction and the bottom of the second fraction. Okay, so you're just going to cross multiply 20 times x minus 2 and 5 times x minus 5. So that's going to give us 20 times x minus 2 equals 5 times x minus 5. Alright, if I work this out a little bit further, that would give me 20x minus 40 equals 5x minus 25. Alright. From here, and this may start coming back to you very quickly, all you're going to do is start to work this thing like a linear equation. So you would start with subtract 5x from each side. That gives me 15x minus 40 equals negative 25. Okay. The next thing that you could do, it would probably help us to add 40 to both sides of the equation. Okay, and that would give me 15x equals 15. I could finish this off by dividing both sides by 15. Okay, because 15 divided by 15 is 1. That gives me x equals 1. Alright, because this was not one of the two values that we said x could not be, this is actually my answer. So the answer to this equation is x equals 1. Alright, so now on to example 2. Alright, example 2 is a little bit different from example 1 because it's not just one fraction equal to another. Okay, so really all you want to do is get rid of what's on bottom. So if you look at the bottom of the first one, you have an x on bottom. So if we want to get rid of that, we would just need to multiply every single thing by an x. Okay, so if I multiply every single term by x, that would help me get rid of at least these two x's here and here. Alright, now I'm not done getting rid of everything that's off bottom. If you look at the second fraction, okay, it also has a 3 on bottom. So I'd also want to multiply every single thing by 3. Okay, and what that does is in the middle one, I'm allowed to divide 3 divided by 3, it cancels out. Okay, so now what I'm left with, I have 8 times 3 plus and 11 times x equals negative 14 times 3. So that's 24 plus 11x equals negative 42. Alright. In order to solve this, just like any linear equation, you'd want to get your x by itself. So we'd subtract 24. Okay, this gives me negative 66 equals 11x. To finish this off, divide both sides by 11, and you would get x equals negative 6. Okay, so before I say that that's my answer, I forgot to look up here earlier and determine what x was not allowed to equal. So because x was on bottom, that means that x was not allowed to equal 0. So since our answer wasn't 0, this actually is a solution and we're done. Our final answer is x equals negative 6. Alright, So on to the third example. Okay, our third example has 3 separate pieces. Okay, we have a fraction 3x plus 5 over x plus 3 equals 2 plus 8 over x plus 3 times x minus 4. What you're going to want to do, again, you want to get rid of every single thing that's on the bottom. So on the bottom of this first one, we have x plus 3. So what I would do is go ahead and you're going to multiply every single piece by x plus 3. Alright, and now if you see what that does, that's going to allow me to see that cancels, this cancels, and if you notice, we're still stuck with this x minus 4 on bottom. So what you're going to want to do is now multiply everything by x minus 4 as well. So if I go back and do that, I would have, see, an x minus 4 here, here, and at the very end, x minus 4. Okay, so what did that allow me to do? That allows me to cancel this here. Alright, so to kind of wrap this up, what you have is 3x plus 5 multiplied by x minus 4, and you have 2 times x plus 3 and x minus 4, and then you have that plus 8 at the end. Okay, so we have a little bit of multiplication to do. If you multiply the first part here, that's 3x times x, which is 3x squared. Alright, 3x times negative 4 is negative 12x. 5 times x is 5x. And 5 times negative 4, negative 20. Okay, that equals, over here, we have x times x, which is x squared, x times negative 4, which is negative 4x, that's 3x, and 3 times negative 4 is negative 12. Alright, so now I have a little bit of simplifying to do. I see that I have some like terms that I can add together, so I'm going to add my like terms. This is going to give me 3x squared minus 7x minus 20 equals 2 times x squared minus x minus 12 and then plus 8. Alright, so this will give me, this left side is still 3x squared minus 7x minus 20. If I distribute the 2 through the parentheses, that would give me 2x squared minus 2x minus 24 and then plus 8. Okay? Now, in this problem, instead of the other problems which ended up with a linear equation that you can easily solve by getting x on one side and getting your numbers on the other, what you're going to end up here is a quadratic equation that you're going to either need to factor or do quadratic formula. So what you're going to really want to do is get every single term on the exact same side. So what I'm going to do just real quickly is I'm going to get rid of everything from this side. Okay, that means that I need to subtract 2x squared, add 2x, add 24, and subtract 8. Okay, so that means that I need to do the same exact thing on the left side. Okay, so that would give me x squared, a negative 5x, and that would give me negative 4. Okay, and on the right side, all of this canceled out, which gives me 0. Okay, and that's exactly what I wanted. Now I have a quadratic that I can either factor or do quadratic formula with, and I can get my solutions. Okay, so let's see. I cannot use 4 and 1 or 2 and 2 to get a negative 5 and a negative 4. This doesn't factor. So what I'm going to need to do is actually use A equals 1, B equals negative 5, and C equals negative 4 to do quadratic formula. Alright, so here's the quadratic formula. We have a negative b plus or minus the square root of b squared minus 4ac all over 2a. And we knew that a was 1, b is negative 5, and c is negative 4. So we're just going to plug each of these pieces into the formula. That would give us 5 plus or minus the square root of negative 5 squared minus 4 times 1 times negative 4. This is all over 2 times 1. Okay, so the first thing that you're going to want to do is you're going to want to do this part that's underneath the square root, not including the square root. So that's, put in your calculator negative 5 squared minus 4 times 1 times negative 4. And what that is 25 plus 36, which is, or 25 plus 16, sorry, 41. And 2 times 1 on bottom is just 2. Okay, so 41. 41 won't reduce any. I can't break it apart using any perfect squares. So this is actually my final answer. And you actually do have 2 of them. You could have 5 plus the square root of 41 over 2 as an answer. And then you could also have another answer, which would be 5 minus the square root of 41 over 2. Okay, so those are your 2 possible answers. You would want to make sure that back with our original problem, neither one of those was listed as a restriction, and so I'm going to check back with that now. Alright, so as I look back at this problem, the only restrictions that we had were from the bottom of the fractions, which would mean that x was not allowed to equal negative 3, and x was not allowed to equal positive 4. Okay, so our answers were fine, and so our answers really were 5 plus square root of 41 over 2 and 5 minus square root of 41 over 2. Okay, and that's it for your first 3 examples.